Hello everyone, this is our next video lecture regarding class 12th chapter surface chemistry and the topic is emulsion. Here we will discuss emulsion, type of emulsion, what is the difference between the different type of emulsion, how you will detect the types of emulsion, what is emulsifier, what are emulsifying agents, what is demulsifying agent, what are the applications of emulsions. So this is a view of emulsion. I can say that emulsions are very beautiful. They look so unique and different from a normal solution. So what is an emulsion? An emulsion is a mixture of two or more liquids that are normally immiscible, that are unmixed. Emulsions are a part of more general class of two-phase system where two phases combine, which is in the form of a colloid. An emulsion is a colloid of two or more immiscible liquids. So we can say that emulsion is a type of a colloid in which two medium both phases are liquids but they both phases are not miscible with each other. Even if you blend them, still then they don't mix with each other. This is the best emulsion which you can see in your kitchen in your day-to-day life, that we have a water and we add oil, then this type of bubbles of oil get separated in a water and this is your emulsion, and this bubbles of oiling in this water is a liquid type of colloid which are not miscible, and this is known as a emulsion. This is what we have a immiscible liquid. We can say that oil and water are not miscible as we all know. So emulsions are of following types, that is water in oil, oil in water, then oil in water in oil and water in oil in water. These two emulsions are extraordinary. Basically we deal with only two emulsions mainly, that is oil in water and water in oil emulsion. So moving to our next, we have this type of a scenario. First, this is your oil in water type emulsion in which water is in large quantity. So these blue dots represents the water molecule and oil in water. So oil is added in water, so it is present in a lesser amount. For example, this here we can say that oil molecules are trapped in the water molecules, and in water in oil type emulsion oil is present in large quantity, so water is trapped in oil. So yellow spots, as I said, represents oil, so these blue spots represent the water. So this is the basic scenario between the oil in water and water in oil type emulsion. So how to differentiate between the flocculation and emulsion? Flocculation I have discussed in the last lecture of this chapter. I will put the link of that lecture in the description box also, and as well in the comment section. So what is flocculation? You know, as you have read the previous lecture also. So flocculation you have studied in last lecture, and now we are discussing emulsions or how to differentiate between emulsion and flocculation. So basically I said you what is an emulsion. It is a good example of emulsion where the one phase is having a liquid, other phase of other liquid is separated, equally distributed. It is a good emulsion. If this spread liquid gray particle which is represented in gray particles get collaborate, combines, coagulate, then it gets flocculation. As I said, in flocculation we have what, the particle get aggregate, so it will be flocculation. And if they get separately, so this is a breaking of a emulsion. And this is the creaming. There is a small, like there is something different from this. Here we can say in the form of a cream, this is spreaded of other liquid is spread over here. So this is a creaming and this is a coalescence when they combine to form a big molecule. This is emulsion, this is flocculation, this is breaking, and we will discuss this scenario one by one. So basically I can say that what is emulsion? Emulsion is a mixing of two liquids, for example water and oil. As I said, when they mix together in a jar or a glass but they do not mix with each other, then the emulsion will form where the separation between the two phases is visible. So next is your type of emulsion. As I said, mainly two types, oil in water and second water in oil. So this is where water is present in large quantity will be oil in water type emulsion. So oil is put in water. So water in large quantity, oil in lesser quantity. And in water in oil type, here water is in lesser amount and oil in more amount. So this is your water in oil emulsion. So I will show water in oil emulsion, that this is oil and this is water molecule. So this is same, this is for oil in water and this is for water in oil. So this blue portion for a water, this yellow portion for a oil. When we add emulsifier, it gets solubilized, so it stabilizes the emulsion basically. We will discuss emulsifying agent later on in this lecture. And this is what I said we used lesser, that is water in oil in water emulsion. We have a water, we have a oil, then again we have a water type emulsion. This is water in oil in water emulsion, and same for oil in water. In the scenario is oil in water in oil emulsion. So the name represents the what type of emulsion it is. For example, if I said water in oil, so which is first, water in oil means water is added in oil, so water is added in oil. And for oil in water we said, so put oil in water means oil in water emulsion. Now next is your difference between water in oil versus oil in water type emulsion. So here in this type of emulsion, the continuous phase is water which is present in a large quantity. Here it will be oil. Here good spread of it is used for, this type of emulsion is used for spreading on a skin, and it may feel greasy like because oil is present in a large quantity. It is sensitive against electrolytes. It is water resistance. It could easily dilute with water because water is present in large quantity, but it cannot be diluted with the water easily. It can be diluted by addition of oil. So it has a high electric conductivity. It has a lesser conductivity because here water is in large quantity, and we know water is a good source of electricity or a good conductor of electricity. And here it is not a good conductor of electricity because oil is present in large quantity. It is not a good conductor of electricity. Even one more thing I will discuss with you, that where this is used, it is useful for night care creams, winter care creams, even foundations, so sun care creams. All that creams are basically your water in oil type emulsion, where water is present in lesser quantity and oil is present in a large quantity. So this is the difference between oil in water and water in oil type emulsion. Here I can say that simply dispersion medium which is present in large quantity. So here water is dispersion medium, here oil is dispersion medium, here oil is dispersed phase, here water is dispersed phase. It is non greasy, it is greasy. It is diluted, it cannot be diluted by adding water. It is diluted by adding water. Water soluble drugs are easily released in this type of emulsion. Oil soluble drugs are quickly released from this type of emulsion, and it is a good conductor of electricity. It is a bad conductor of electricity as oil is present in large quantity. Now next is your how to detect the type of emulsion. By naked eye, it is difficult to differentiate that whether it is oil in water type emulsion or it is a water in oil type emulsion. Thus, we used methods to check the type of emulsion it is. First method is dye test, second method is dilution test, next is your electrical conductivity, and the next method is your fluorescence test. So we will discuss these tests one by one. First is your dye solubility test. So we have unknown emulsion. We don't know whether it is a water in oil type emulsion or it is a oil in water type emulsion. What we do, let's say for example we take a dye which is soluble in oils. Normally dyes are soluble in oil, so we put dye in a container which is carrying an unknown emulsion. If the majority of the portion of that dye gets the color of the dye, if the majority of the portion of the beaker in which unknown emulsion is there gets the color of the dye, that means the emulsion is water in oil type emulsion because dye is soluble in oil. So as dye is present in a large quantity in that solution, that means oil is present in a large quantity. And if we add a dye in a solution but the little droplets of that liquid of unknown emulsion get a color of a dye, that means we have a oil present in a lesser quantity, so it will be your oil in water type emulsion. This is the good way to check the which type of emulsion it is, by putting the dye which is oil soluble one. For example, here I can say, here we have a red color dye which is soluble in oil. When we put it in a beaker, we get a majority portion in a red color, so it means here the dye emulsion is your water in oil type, and here the droplets of the emulsion get color, that means it is a oil in a water type emulsion where water is present in a large quantity. Moving to next, second test to check the type of emulsion is dilution test. So what we do in this test, simply we if the emulsion is not known and we add water, and if by adding the water the phase change will not take place, so the level increases, it means before mixing of water unknown emulsion contains main, or we can say unknown sample of unknown emulsion contains water in a large quantity, so it get diluted easily. But by adding the what oil in that emulsion, we get a phase change, so we can check it is a water in oil emulsion or a oil in water emulsion. If by adding the oil the level of emulsion increases and no separation is there, that means it will be your water in oil type emulsion. If by adding water dilution happens, then it is your oil in water type emulsion. But if on adding oil dilution does not occur, then it means it is your water in oil type emulsion, so the phase separation will take place. This is the way to check the dilution or a test of a dye. Third test is your electrical conductivity test. Simply we take unknown emulsion here, and what we do, as we know that oil in water is a good emulsion for a conductivity. So we know that water is good conductor of electricity, whereas oil is a bad conductor. If oil is present in lesser quantity, it means it is a oil in water type emulsion. That means water is a continuous phase, means it is a dispersion medium, so conduction will be there. But if the conduction does not take place, then it will be your water in oil type emulsion. So they check it by using this setup, and if the bulb glows, it means it is oil in water type emulsion, and if it does not glow, it means it is a water in oil type emulsion in which continuous phase is oil. So because of that it do not glow, because oil is a poor conductor of electricity. So moving to next test, fluorescence test. In this test, what we will do, as we know, oil gives fluorescence under UV light while water don't. Under UV light, oil gives a fluorescent color, but water have no color. Therefore, if we check emulsion and if it gives a fluorescence color, that it means the water oil is present in a large quantity, so it is your water in oil type emulsion. But we do not observe this type of color, so we can say that it is your water oil in water type emulsion. So I will give this work to you. Try yourself that which is a type of emulsion, whether it is a emulsion or it is a colloid. It is a emulsion or a colloid. This is your emulsion or a colloid. Butter is a emulsion or not, and ghee. Just think over it what you have studied, that whether these are colloids or these are emulsions. If these are emulsions, then what type of emulsion it is. Next is your emulsifier and emulsifying agent. So a substance that stabilizes an emulsion in a particular and additive to use to stabilize the things, especially for a processed food. So I can say that emulsifier is substance which stabilize the emulsion, basically used for the processed food which we buy from market, that are packed food materials. So an emulsion can be stabilized by addition of an emulsifying agent. So this is emulsion, and by addition of a stabilizer we get this type of a stability in an emulsion. So what the function of emulsifying agent, we can say emulsifier or a surface active agent is a molecule which has two parts, hydrophobic and hydrophilic. Hydrophobic is water loving, hydrophobic is water hating. So upon addition of it in emulsion, we will see that they trap the oil particles, that means they trap the hydrophobic part inside with the hydrophobic and hydrophilic outside. So what we can check that if the micelle formation take place, then what it is, it will be your oil in water type emulsion. So it is a good way to check even the type of emulsion, or I can say it will stabilize. Basically the oil which is moving in a liquid, when we add detergent or soap in it, it gets stabilized by the formation of micelle. So this is what happens, we get a droplet and here the particles are disturbed, and we add emulsifier stabilize this by adsorption, by increasing the adsorption. Here the adsorption take place slow and here it is fast. So this, with the help of emulsifier, it is easy, because we know that we are studying chapter surface chemistry and we started this chapter with the adsorption. So this is what emulsifier does, and this is the good structure, or we can say diagram, for a emulsion emulsifier which this is the hydrophobic and hydrophilic parts, and this is the emulsifier and it traps the oil. Now this is emulsifying agent. There is a separation of the things, and after the addition of emulsifier we get this type of liquid where the difference or distinction in the phase is there. It gets stabilizes by mixing properly because of the presence of the emulsifier. So emulsifying agent type of, they can be synthetic, they can be natural. Synthetic, which are man-made, we made them, for example surfactants which contain hydrophobic part, hydrophilic parts, and as we discussed in the micelle section that the surfactants are ionic, cationic, non-ionic, and natural are from the plants or the animals. For example, they are protective colloids which reduce the flocculation or collenses that particles get trapped. So these are present in the fruits and vegetables. For example, food emulsifiers are egg yolk, which is the main emulsifying agent, and mustard is a good emulsifying agent. So these are the some food emulsifying. So this is what effect of emulsifier on a mayonnaise. This is a mayonnaise sauce which we use to have a momos. This mayonnaise looks like this. What we have usually. This is because of the presence of emulsifier. But if we don't add emulsifier, or we can say before addition of emulsifier, this mayonnaise look like this. I don't think after having this type of mayonnaise anyone want to have it, but after watching this mayonnaise everyone want to have it because it looks good to have. So this is the effect of emulsifier. It gets stabilize the things. Here the phase separation is there, but after adding of emulsifier we get this type of a mayonnaise which look good and tasty also. Now the next is the effect of emulsifier on mayonnaise. I told you earlier, this is what I will say, that the oil separation is there which is seen easily here. This is oil separation, and this is what after addition of the emulsifier we can say. So moving to next, an emulsifier or emulsifying agent is a compound or substance that act as a stabilizer for emulsions, preventing liquids that ordinarily do not mix from each other or separating, and the word it comes from the meaning to milk in reference to milk as an emulsion of water and fat, as we know that milk is a good emulsion of a water and a fat. Now next is, what is demulsifying agent? So it is a emulsion breaker also. It is a class of a chemical which is used to separate the emulsions. For example, water in oil type emulsion, these are basically used for the saline water removal of the impurities, or I can say that demulsifier is basically a emulsion breakers which are used to break the emulsions. This is what they do. There's the separation, there is good emulsion, but after addition of the demulsifier we get a phase separation. This is the function of demulsifier, or in a simple way we can say that demulsifier have a function opposite to that of the what emulsifying agent has. So these are used to break crude oil emulsion in the natural structure, or we can say on demulsifying agent the following properties are modified: surfactant behavior at water oil interface, ability to flocculate. This is what emulsified crude. This is emulsified crude. Here the emulsion, this is a good emulsion. On heating this emulsion gets separated, so demulsifying agent work and we get a separation. So this is a demulsified crude which is easily visible to us. So how we can do or type of demulsifying processes: by chemical methods, by thermal, by electrical, by mechanical. Chemical, you know, by addition of any chemical we can do the or reverse the effect of emulsifying agent. By using thermal method means by heating we get reverse effect of the emulsifying agent. By electrical methods we can do demulsification, and by mechanical method we can do demulsification. This is the effect of the demulsification. This is a good emulsion here, and here this is the difference in ppm. And ppm we know, we studied in chapter solution. So here the applications of emulsion. Where the emulsion are used? Basically emulsions are used, as you know that milk is a good emulsion of a fat and oil. Further, cosmetics, lotions, creams, all are made up of emulsions. All are a type of emulsions. Then photographic plates, which are coated with silver bromide, is the good example of emulsion. Then again, the cleansing action of soap is a emulsion. Even the drugs which are available are a good example of emulsions. So this is all the emulsion. Even the metallurgy process is done, that is froth flotation process. It is an example of emulsion. This is what we have a oil in water type emulsion, and this is butter. Here we have a water in oil type emulsion. This is the best example for emulsion, I would say, and this is the thing you use in your daily life. Next is your colloid versus emulsion. Colloids are homogeneous non-crystalline substances consisting of large molecules or ultra-microscopic particles of one substance dispersed through a second substance, where emulsion is a fine dispersion of a minute droplets of one liquid in another. Here in colloid we can say that they exist in all three states, but emulsion exists in a liquid state only. So this is the best difference between emulsion and a colloid. So I will leave this to you. Differentiate between both, which is colloid, which is emulsion, and if it is a emulsion, which type of emulsion it is, and if it is a colloid, then still check which type of colloid it is.